So page 13, continuing with an example here. I'm going to write a full program, so I've got to include two header files. I'm going to use printf, so I need standard io.h, and I'm going to use malloc. And so for malloc, I need to include standard lib.h. And I'm going to declare a string here, char s square brackets, and I'm going to initialize it with this string literal abc, and remember that there will be a null character at the end of that, so the storage for s will be four chars. And now the main. I'm going to declare a local variable here. I just realized that I forgot to include standard int .h for this example. So that's where uint32t type is declared. Let's call this m, and let's give it a value of 4, not that that really matters. And I'm going to create another local variable, but this one is a pointer. So, and it's going to have the address returned by malloc, and we're going to ask malloc to allocate the number of bytes for a uint32 type. So if you're picturing this in memory, you can think, where is s going to be located in that diagram? Where is m going to be located? Where is p going to be located? And the thing that p points to, where is it going to be? And you should be able to answer all of those. So I'm going to print all of those out. So you can print a pointer using the %p conversion specifier. And I compiled and ran this on a Linux machine, and the largest address that it printed was 14 digits wide. So I'm going to make them all 14 digits wide so that they all line up on the right side. And then add a new line and repeat. So %14p \n, %14p \n, %14p \n. And now so I've got 4 pointers that I want to print. Now remember I told you that arrays, the array reference or the array identifier is actually a pointer, in this case a character pointer. So I can just pass it s, and I'm just going to leave a little space between these so that I can write underneath them. Going to pass it the address, so that's the address operator, address of m, so that we can figure out where m is being stored. I'm going to pass it the address of p so we can see where p is being stored, and the address and the contents of p, which is, where is the dynamic memory coming from, which you should know. Just to make a note here, %p is the pointer conversion specifier, and so s is a global, so we should see that it's at a relatively low address. M is on the stack, so we should see it coming from a high address. P, the local variable, is on the stack, so we should also see that at a high address. And then what P points to, the address that it contains, is on the heap. And so we should find that that's an address between the globals and the heap. And let's just close the main here, and I'm going to write out what the output is here. And I usually use this goldenrod color, so let's write the output. And I'm going to be careful about lining up the characters here. So this one needs to be over to the right a little bit, and this is 601050. I mean, the details don't really matter, but I just want you to see the relative size of them. And the next number, I'm going to write backwards to the left of the 0, just to make sure that I line things up properly. So that's the start of the hex number, 0x7FFF. And then underneath that, lining each digit up, we've got D, C, D, 8, A, F, A, 4. So that's a pretty big number. That is not the highest address that you can generate using 64-bit pointers. I did this on a 64-bit machine, but they don't actually use they don't use 64 bits worth of memory. It would just be too big. So that's a 48-bit address. Okay, so that's the address. So let me just switch my color here. So this is the contents of S. And the next one was the address of M, which is on the stack. Let's keep going with the next one, the address of P. And it's all the same except for the last digit is an 8. So that's where P is being stored. The address in the heap starts underneath the last F there. So 0x 2 5 2 E 0 1 0. So P is on the stack, and you see that that address is greater than where S is in the data segment, but it's less than P and M, which are local variables. So there, you can write a program to investigate, where things are being put in memory. If you want to figure out where the address of something in the in the text segment is, you could go back to what I talked about the other day, strings. I did this in a slide where I showed you that if you initialize a char pointer with a string literal, it'll actually take on the address of that string literal. And I think that you would find that that would be a lower address even than the variable that's in global. It should be an address in the text segment. All right, that's it.